In this video, we'll discuss how to balance nuclear reactions. First off, let's talk about radioactivity or radioactive decay, which is simply when a nucleus breaks apart or decomposes and a new nucleus is formed. Not only a particle is emitted, but this nucleus has a different mass and a different identity. It'll be a different atom altogether. We want to look at how to notate our different isotopes. So this is called isotope notation. The E right here, this would be the symbol. So like an H for hydrogen or He for helium. The mass number is A. That's the number of protons plus neutrons. The atomic number is the number of protons. So we're going to use this isotope notation throughout these balancing of nuclear reactions. The three main type of decay are alpha, beta, and gamma. Alpha can also be written either of these two ways. Beta can be written like this, and then gamma is just this funny looking little symbol right here. The energy emitted from an alpha particle is pretty low, so it can't even penetrate paper. But the beta particle can penetrate paper, but it'll be stopped by something like aluminum. And then gamma is so powerful, it has so much energy that it can penetrate paper and aluminum, but it cannot penetrate lead. So alpha decay is where an unstable nucleus emits an alpha particle and forming a different nucleus. And here's an example. We have the alpha decay. So originally we had a mass of 177, an atomic number of 79, and the identity is gold. But after the radioactive decay, the new particle becomes, the mass decreases by 4, number of protons decreases by 4, it has a new identity, and it has emitted an alpha particle. So if you look here, 173 plus 4 is 177. 77 plus 2 is 79. And then if you look at the number of protons here, that will give you the identity. You just use the periodic table to find the symbol. If we look at this example, we want to take this reaction. The unknown is the standard default isotope notation. And we want to figure out what this particle is. What does this become after it emits an alpha particle? So it's just simple math, right? 4 plus 224 is 228. 89 plus 2 is 91. And then if it has 89 protons, we know that we just look at the periodic table for the atomic number to find the symbol for that particle or that atom. We have beta decay. Beta decay is when a nucleus emits a beta particle, and this is a beta particle right here. So you can see that our mass doesn't change. The only thing that changes is the atomic number, which changes the identity of that atom, and then it emits the beta decay. Just like the other example, we have to find the identity of the unknown particle, and the way we do that is we do the math over here. 77 plus 0 is going to be 77. 32 minus 1 is 31, and 31 protons gives us the identity of that atom. Now, for honors, I want y'all to look at the third type, positron decay. This is where the type of radioactive decay occurs, and the a proton is converted into a neutron. So this is the proton, or the positron. So we have our initial atom, it emits a positron, and in the process, one of the neutrons, or sorry, one of the protons becomes a neutron. So the mass doesn't change, only the number of protons changes. So we go from 7 down to 6, and in the process you have a positron that's emitted. So we do the same kind of math we've been doing. 144 plus 0 will give you 144. 67 plus 1 is 68. Use the periodic table to find the symbol for that.